Okay, this lesson is going to be about lesson 8.8, which is going to be on applications of trigonometry. Now, this lesson is just going to be about, we're just basically giving you real world questions, and you are either asked to fill in the blanks based on the picture that's given to you, or you're going to be asked to draw a picture. Now, in order to be successful in this lesson, you do have to know key terms here, which is that you have to know what angle of elevation and what angle of depression means. Angle of elevation basically means you have an angle that's formed between a horizontal line. First of all, horizontal line is when you have lines that's like this. So angle of elevation is the angle that's formed between a horizontal line and the line of sight that's looking upward to an object. So if you look at this person right here, here's my line, horizontal line, and my angle of elevation is formed when my other line that formed this angle is actually going to form a sight or going up, pointing upwards. Now, this angle that's formed by these two lines here will be called angle of elevation. Now, angle of depression is kind of like the opposite. It's formed by my horizontal line, so right here. And the other line that makes up my angle has to be looking downwards. This makes my angle of depression. Now, let's practice how to find, how to determine these angles on example 1. Example 1 here says, in the picture to the right, mark each angle as the angle of elevation, E, or as the angle of depression, D. Now, angle 1 here, angle 1, we're looking at angle 1 from the bird to the man in the balloon. So we're looking from the bird to the balloon. And we have a horizontal line right here. Now, if we have a horizontal line, key thing though, with angle elevation and depression, you must have a horizontal line. Actually, if you have your paper, go ahead and please highlight or circle horizontal line. You really need a horizontal line for it to be one of these, angles. Now, angle 1 is formed by a horizontal line right here, and it's having another line that's actually pointing downward. If we're pointing downward with that horizontal line, with it, then it's going to be angle of depression, or let's put D. Looking at angle 2. Angle 2, it says that we're looking from the man in the balloon right here to the bird. So we're looking upward. So we're looking upward and we have a horizontal line right here. So if we're looking upward with a horizontal line, that's going to be elevation. So let's put E. Next one. Let's go ahead and do angle 3. Angle 3, we're basically from the man in the balloon and we're looking down to the base of the mountain. So we're looking down and we have a horizontal line right here. Now, this have a horizontal line, it's looking down, so that's going to be angle of depression. So I'm going to put D. Last one, same kind of idea. We're going to look from the base of the mountain. This is a horizontal line, and we're looking at the person in the balloon. So we have a horizontal line and we're looking up, so that's going to be angle of elevation, or we're going to put E. Now these ones are pretty straightforward. Let's look at a couple of confusing ones just to test your understanding, okay? So example 2, we're going to identify each of the angles as angle of elevation, depression, or neither. So let's look at angle 1 first. Angle 1 is right here. Now angle 1, the two lines that form these angles, if you look at closely, none of these is a horizontal line. Some of you guys might say, oh, this is looking down, so it's depression. No, this is not depression. Because in order to be a depression, angle of depression, it has to be an angle between a horizontal line and a line that's going downward. Now, if you look at this, we have a line that's going downward right here, but the other line is not a horizontal line. So it's going to be neither elevation or depression. So it's going to go right here. Angle 1. It's none of these two categories. It's going to go right here. Now let's look at angle 2. Now angle 2, we have a horizontal line and it's going downward. So therefore, it's going to be depression. Angle 2 belongs to depression. Let's go ahead and try angle 3. Angle 3, we have a horizontal line right here and we're looking upwards because the other line is going upward. Now, this will be going to be elevation. So angle 3 will be elevation. Let's go ahead and do angle 4. Angle 4, we have a horizontal line, and my other line is going downward. So it's going to be depression. Angle 9, let's take a look. angle 9 right here is actually this whole angle from here to here. Now we have our horizontal line right here, and the other line is going upward. So therefore, it's going to be elevation. Okay, I'm going to erase this. Now let's go ahead and take a look at angle 8. Angle 8, as we can see, is right here and here. Now, do I see any horizontal line here? No. So therefore, it's going to be neither. So I'm going to put angle 8 right here in this category. Now, I think we're still missing a couple, but you can try it on your own, okay? As long as you get the idea, it's good. Now, let's go ahead and move on to example 3. Now, with these word type of questions, you really do have to, circle everything that you have. Circle any important information that you're doing, and then fill out everything on the picture, or draw the picture out sometimes. Now, it says an airplane is approaching a runway with an angle of depression of 23 degrees. Now, first thing, airplane is approaching a runway. Our airplane is drawn for us, but where's our runway? So let's go ahead and label our runway, which is right here. Okay. Now it says that my airplane is approaching at the runway with an angle of depression of 23 degrees. Now, angle of depression is when you have a horizontal line and you have another line that's pointing downward. Now, think about where could this be? Now, if you look at it, the only place that this could be will be right here. This is my horizontal line. I'm going downward. So my angle of depression will be here, which is going to be 23 degrees. The next key information right here says the plane is 5,000 feet away from the runway. Well, 5,000 feet. Let's go ahead and highlight it. If it's 5,000 feet away from my runway, it means that from here, the plane, to my runway here, the distance in between, from here to here, must be 5,000. So let me put it down. Now, the last piece of information is the question that they're asking for us, which is, what is my altitude of my plane? Now, on these questions, whatever they're asking for, that's why I want you guys to mark it as X. Okay? Now, what is my altitude of my plane? Well, altitude is basically the distance of the plane to the ground. This is what they're asking for us. Now, the plane, from the plane to the ground, is this length right here, right? This is the length. Now, in order to go ahead and find this, there are a couple of ways to do it, though. One way is that you can take this triangle right here. I'm going to show both ways, okay? So method 1 is that you're going to take this triangle right here, and you're going to use this triangle to solve for my missing height. Now, if you're doing this way, first of all, I know that this right here is what I'm trying to find. So this is the X. But I also need other information, like the angle, because I need a reference angle, which I can know what angle is right here very easily, because I know this part right here and this part right here forms a 90-degree angle, because one is a straight vertical line up and down, the other one is a straight horizontal line. So it must form a right angle. Now, if this form a right angle here, and part of my degree is 23 degrees, what must this angle right here be? Well, you have to do 90. You will have to do 90 minus 23, which will get you your favorite number, which is going to be 67. So this will be 67 degrees right here. Now, if you choose to do it this way, then let's look at our triangle. Okay, so we know our triangle, we have a side here, that's X. We have a 67 degree as our reference angle, so let's circle it. And we have the, right here, my hypotenuse is 5,000. So using this, let's use SOHCAHTOA. So let me write down SOHCAHTOA. After I circle my reference angle, I need to determine what type of side do I have. I know my X will be my adjacent, and my 5,000 will be my hypotenuse. If I have adjacent and hypotenuse, I need to use cosine. I need cosine equals adjacent over hypotenuse. Now I'm doing cosine of what reference angle? I'm doing cosine of 67. So I put cosine of 67 equals adjacent over hypotenuse, which is X over 5,000. Now, I just had to multiply both sides by 5,000. Okay? And once you do this, you should be getting your x as, because on the right side cancels, your x here will be 1,553.7 feet if you round it to the nearest 10th place. Now, this is one method to do it, which in class, I showed you a different method. Right, let me go ahead and erase. Okay. In class, I showed you a different method. On the video, I'm making, two solutions so you guys can look at it. In class, I say that this is the runway, this is 5,000 feet, and I know I'm trying to find this right here is 23 degrees. And I'm trying to find my height. Now, I know this height right here, if this is the height right here, then this is also the same right here. This is also the height of the plane to the ground. It's also the same. Okay? So, how about, since I have this 23 degrees right here, how about I just use this triangle right here on the right? Because it's already having every piece of information that I need. So let me use this. Well, same thing. I circle my reference angle. Oops. And then I look at what type of side do I have. Well, the x in this case is my opposite, and the 5,000 is still the hypotenuse. If I have opposite and hypotenuse, which one will I use out of the SOHCAHTOA? It'll be so. So I need to write sine equals opposite over hypotenuse. Now, once you got this written down, let's set up the question. So write down sine. Next to the sine, I write my reference angle, which is 23, equals to, well, opposite over hypotenuse. Opposite is x, hypotenuse is 5,000. Now, in order to cancel out this 5,000 here, I need to multiply both sides by 5,000, which on the right side cancels out, gives me x. On the other side, it will be the same answer if you put in the calculator. It will be 1,953.7. There's different ways to approach this question, but as long as it ends up with the same correct answer, it's totally okay. Now, looking at question B, it says a man is standing 100 feet from the tall building. Now, let's stop right here and highlight the important piece of information. We know a man is standing 100 feet away from the building. Okay, that measures the angle of elevation to the top of the building from the point where he's standing. If the angle is 62 degrees, and this angle 62 is from where he was standing to the top of the building. Approximately how tall is the building? Okay. There's a lot of information at once, but let's take it step by step. Okay, looking at the first one. It says a man is standing 100 feet from the tall building. Well, let's go ahead and draw a little man. Let's say that man is right here. This is the man. Okay, I'm gonna draw him a hat. He's standing 100 feet from my tall building. So this means the distance from here to here must be 100. Okay, now let's look at the second part. It says, well, the angle of elevation from the building, from where he was at to the building was 62 degrees. So this means this right here must be 62 degrees. Now there's there's two ways you can get this 62. One way is that you can just look at it, well, it's from the person to the building, so it must be here. The other way, you can take the elevation part as a hint, because I know elevation must be a horizontal line, and the other line must be going up. And the only one that fits in this picture is only right here. Okay, now, lastly, we're going to label where is our x, or what are we trying to find. Now, it's asking us how tall is the building. Well, the tallness of the building is right here. So this I'm going to label as x, because this is what I'm trying to find. Now, once you have everything, we can start to set up our question. Now, remember, whenever you're trying to find a side with a given angle, or when we're trying to find angle with given sides, we're using SOHCAHTOA. Okay, now, I'm going to first always circle my reference angle. Right here, this is my reference angle. And now I'm going to determine what type of side do I have. What type of side is my 100? Well, my 100 in this case is the adjacent. What type of side is the x? In this case, it will be the opposite. So if I have opposite and adjacent, which one of these SOHCAHTOAs will I use? Oops, I made a mistake right here. This is actually A. Which of these SOHCAHTOAs will I use? Well, if I O and A, then the one that I will use will be the tangent. So let me put it down. Tangent equals opposite over adjacent. Now, I need to write everything out. Tangent of what reference angle? tangent of 62. So I put tangent of 62 equals to opposite over adjacent. My opposite is my x, and my adjacent is 100. And this is how I should set it up. Now, next step, well, in order to isolate my x here, I need to multiply both sides by 100. So this way, on the right side, this cancels and gives me x. On the other side, tangent of 62 times 100 will give you your answer here as 188 feet. And that will be your answer of how tall the building was. Let's look at another question. So Lily is standing 200 feet away from a 50-foot tall building. So let's go ahead and draw our Lily. She's right here. This is our Lily. She's standing 200 feet away. So 200 right here from a 50-foot tall building. So we know the building is 50 foot tall. What's my angle of elevation does the Lily look to see the top of the building? My angle of elevation in this case, remember, is when the horizontal line and another line is that is pointing upwards. So in this picture, it'll be right here. This right here, x degree, will be what we're trying to looking for. Now, in order to figure this out, we still have to use, our trigonometry ratios. So let me write down SOHCAHTOA. Whenever you're doing these questions, write down SOHCAHTOA. You will never make a mistake. So now let's first circle my my reference angle, and then determine my type of side. 200 is what type of side? 200 in this case is my adjacent. 50 in this case will be my opposite. So I have opposite and adjacent, I will have to use tangent. So let me set it up. Tangent equals opposite over adjacent. Now, next to my tangent, I have to put my reference angle. If I'm trying to find my reference angle, I'll just put x equals. Now, opposite over adjacent will be 50 over 200. Now, to cancel out my tangent, so I only have the x left, I need to take tangent inverse on both sides. So I will do tangent inverse on both sides. Okay, this way, on the left side, this cancels out because tangent inverse and tangent is just like plus 2 or minus 2. When you do both, it cancels out to 0. Which will just leave you with the x. On the other side, tangent inverse of 50 over 200 will be, if you put in a calculator, will give you 14 degrees. Okay, and that's going to be your answer to this question. Now let's go ahead and try to do question D. So question D says, while Ryan is standing on the top of the building. So now, to make it a little bit better, let's make Ryan a cat, okay? Ryan's a cat. Ryan's a cat that's sitting on top of the building. Now, Ryan's a baby cat. He's accidentally got on the top of the building, and he needs to be rescued by the fire department because he's so little, he haven't learned how to jump yet, okay? Now, the fire engine, which is the car that the firefighters drove in, is 10 feet tall. Right here, 10 feet tall. And it has a 50-foot ladder that's going to reach the building to the cat, right here. Now, if the angle of elevation is 64 degrees, which I already labeled for you, when the ladder reaches the top of the building, how tall is my building? So my main goal here is I'm trying to find what's the length from the building all the way to the ground. This is what I'm trying to find. Okay? Now, in order to find this, first of all, I know this is the whole length right here, right? But I know part of the length is actually given to me because, look, right here, the car is 10 feet tall, meaning from here to here, it's going to be 10 feet. So all I need to do right now is just to find this missing length right here. Then I can know what's my total length of the building. Because all I have to do is I'm going to figure out this x here, and then do x plus 10. That'll give me my whole length of my building. Okay, now let's find my x. Well, on these questions that when you're given an angle, you're trying to find side, you use SOHCAHTOA. So let me write down SOHCAHTOA. Okay. So let me circle my reference angle, which is 64. Circle it. Well, what type of side is this 50 right here? Well, remember, if you have a horizontal line and you have a straight up and down vertical line, this forms a 90-degree angle. Now, this means my 50 right here, that's the side that's opposite away from my right angle, will be the hypotenuse. So I have my 50 as the hypotenuse, and my x right here is actually the opposite. So I have opposite and hypotenuse. Which one do I use? Well, I'll use the SOHA. So I'm going to write down sine equals opposite over hypotenuse. So sine of what though? what is my reference angle? 64. So I write sine of 64. On the other side, opposite over hypotenuse. Opposite is x. Hypotenuse is 50. Now, I just need to isolate my x. Well, what do I need to do both sides if I have x divided by 50? I will just multiply both sides by 50, right? Let me go ahead and cancel these out so you guys don't get distracted. Now, on the right side, this cancels, give me x. On the other side, if you put in the calculator 50 times by the sine of 64, that will give you 44.9 feet. Now, does this solve my question? The answer is no, because this 44.9 is actually the height of this building to the top of the car. But we need to know the length of the whole building. This means we need to take this 44.9 plus this 10 right here, because right here is 10 feet, right? So we need to do 44.9 plus 10, and that will give us my building's height as 54.9. And that solves our question, and it's going to be in feet. Let's go ahead and go over two more. Now, a fruitful tall boy is flying a kite on a windy day. The boy lets out 100 feet of string. Let's go ahead and highlight it. 100 feet of string that forms a 32-degree elevation. Now, what is my height of my kite? Now, take it step by step. My 100 feet is going to actually be right here. This is 100 feet because it's the length of, my kite string. Okay? Now, it forms an angle elevation of 32 degrees. Remember, elevation is when you have a horizontal line and the other line is going up. So where is it on my picture? It's actually going to be right here, 32. It's asking us, what's my height of the kite? Now, some of you guys might make a mistake and be like, oh, this must be my height. No, that's not it, okay? My height is actually from the kite to the ground, all the way from here to here. Now, in order to solve this question, just like the last one, it's going to be a multi-step one, okay? So, the boy is actually going to be 4 feet. We know this for sure, okay? Now, if we know from the height to the ground, part of the height was the boy's, from here to here, it was 4. Now, all we need to know is what's the height of this kite to the, to the head of the boy. Then we can just add this part right here with this part to figure out our answer. Now, let's figure out this missing value here. Let me just label it as x. And whenever you're trying to find a side with giving angle, we can use SOHCAHTOA. So let me write down SOHCAHTOA. Now, let me circle my reference angle. And according to my reference angle, my x here is the opposite, and my 100 here is actually the hypotenuse. Well, which of the SOHCAHTOA do I use? I use sine because it's SOHCAHTOA. It's O and H. It's only in sine. So I put sine equals opposite over hypotenuse. Now, write it down, sine. Well, sine of what angle measurement is 32 degrees. So I put 32 equals opposite, which is x, and hypotenuse, which is 100. Now, in order to find my x, I need to multiply both sides by 100, like this. On the right side, it cancels, gives me x. On the other side, 100 times by the sine of 32 will give me my x here as 53. Now, is 53 my total height of the kite? The answer is no, because the 53 is actually just the height of the kite to the head of the boy, which is right here. But I need this whole length from here to here. Well, what do I need to do? I need to add 53 plus the height of the boy, which is 4, and that will give me the total height of the kite, which is going to be 57 feet. Now, question F is going to be a little bit challenging, but I want to leave it to you guys so you guys can try it for extra credit. If you actually finish it and I see on your workbook when I check it, it will be extra credit.